This is section 6.6, Solving Absolute Value Inequalities. Before we begin, we have to review absolute value. Remember that the absolute value of x means the distance between x and 0 on the number line. It's the distance between the variable and the origin. So it could go into negative or positive numbers, but because you're measuring distance, distance is always positive, so absolute value is always positive. If you take a look at the absolute value of x is less than 3, what that really means is that the distance between x and the origin is less than 3. On a number line, think about what that means. Take a look here. Because we have a less than sign, that means we have open circles on 3. The absolute value of x is less than 3, so we're going to go left of 3. But we can't go past negative 3, because if we do, then the absolute value of x would be greater than 3, because the positive distance would be greater than 3 if we took the arrow all the way to negative 4. So the graph has to remain between negative 3 and positive 3, the two ends of the absolute value equation. In the same way, the absolute value of x is greater than 3 would mean the distance between 3 and the origin is greater than 3. So that means the graph is going to be above positive 3 and below negative 3. So it splits in the middle, right? It's like the OR inequalities that we've already looked at. If you try this next one, the absolute value of x is greater than or equal to 6. Again, that means the distance between x and the origin is greater than or equal to 6. So in this case, we need to graph above the 6 and below the negative 6. But in this case, because it's a greater than or equal to sign, we need to fill these circles in. So we're going to color these in so that they're solid. In other words, the 6 and the negative 6 are included in the group of numbers that make this inequality true. If we look at the absolute value of x is less than or equal to 0.5, that means the distance between x and the origin is less than or equal to 0.5. That means it's within 0.5 on either side of the origin. So it goes to positive 0.5 and negative 0.5. And you can see we filled in both the 0.5 and the negative 0.5 because they're included in the solution. Looking at the graph, that you can now see that the absolute value with a less than can be rewritten as a compound inequality. So this is an AND inequality. You can see that the x is going to be less than or equal to 0.5, but greater than or equal to negative 0.5. Right? This is really, really important. Whenever there's a less than or less than or equal to, you're going to have a graph that's in the middle of 2 points. So it's an AND inequality, a compound inequality. The key rules for solving absolute value inequalities are this. If you take a look at the inequality, the absolute value of ax plus b is less than c, where c is greater than 0. Okay, c has to be greater than 0 because absolute values are always greater than 0, right? It's equivalent to the compound equality negative c is less than ax plus b is less than c. And the inequality absolute value ax plus b is greater than c, where c is greater than or 0, is equivalent to the compound inequality ax plus b is less than negative c, or ax plus b is greater than c. Right? I know that sounds really confusing. But what it's saying is when you have an absolute value with a less than sign, you can rewrite it as a compound inequality. So here, in the first case, this one right here, okay, when you take a look at that, all we've done is taken what's inside the absolute value and we've put it in the middle here. And on either side of the inequality symbol, we've used the positive value of c and the negative value of c. That's key. You are going to follow this pattern every single time. It's completely different, though, when you have a greater than sign, because a greater than sign with an inequality creates an or. It creates two different inequalities. So now you have it equivalent to ax plus b is less than negative c, or ax plus b is greater than c. So you write one of the inequalities just like the original, but you remove the absolute value sign, and you write another one that takes the original, changes the sign, and then changes the value of the c by putting a negative in front of it. Can you see that? You really have to learn these forms or you're going to be very confused. If you remember that less than is always a compound inequality, the middle of a graph, then I think it will help you write that first form. But a lot of students get confused with this switching of the signs in both the inequality and before the c. So you really need to pay attention to this as you practice these problems. Of course, these will also work with less than or equal to or greater than or equal to. So here's an example. If we have the absolute value of x minus 5 is greater than or equal to 7, you have to think. First, it's greater than. So it's an or compound inequality. That means we're going to write two different inequalities and solve them separately. Okay, so the first one is going to take the original, x minus 5, but change the sign of the inequality and change the sign of the c, of the 7. So we have x minus 5, right here, is less than or equal to negative 7. So x is less than or equal to negative 2. Now the or comes in with the other case, okay? And the other case is actually the easier case. We take the original problem, x minus 5, and we just solve it for greater than or equal to 7. So we're going to add 5 to both sides, and we get x is greater than or equal to 12. Now when you graph this, knowing that it's an or, you know it should go in two opposite directions with the middle being blank on the graph. If that does not happen, you've done something wrong. So let's do it. On the first one, we have x is less than or equal to negative 2. So I've put a solid circle on negative 2, and I've drawn to the left for less than. And the other one, I have x is greater than or equal to 12. So again, I've filled in the 12, and I've done greater than. So my graph is going the correct way for a greater than or equal to absolute value inequality. Now in example 2, we're going to take a look at a less than absolute value inequality. So I have the absolute value of 2w minus 1 is less than 11. Because it's less than, right away you know it's going to be written as one compound inequality with that absolute value in the middle of two inequality signs. So this is actually going to become negative 11 is less than 2w minus 1, which is less than 11. To solve it, you solve it just like you were doing in 6-4 in our previous sections. You're going to add 1 because we want the w's all by themselves. You're going to try to isolate the variable here. So it becomes negative 10 is less than 2w is less than 12. Then divide by 2. So you get negative 5 is less than w is less than 6. To graph it, I put open circles on 6 and on negative 5, and then I color in, I fill in between, because the graph, the w, has to be between those two numbers. Now to solve a more difficult inequality, we're going to throw a little wrench in the works here. We have the absolute value of negative 4x minus 5 plus 3 is less than 9. Before we do anything, we have to isolate the absolute value part of the inequality. You need to have that by itself on one side. So you have to subtract 3 from both sides and rewrite it. So I have the absolute value of negative 4x minus 5 is less than 6. I'm going to rewrite this because it's a less than. It's a compound inequality. So we're going to have negative 6 is less than negative 4x minus 5 is less than 6. I have to add 5 to all sides, not both sides, all sides here. And when I do that, I get negative 1 is less than negative 4x is less than 11. Now, here's the tricky part. I have to divide by negative 4 to get x all by itself. But when I do that, I have to reverse all the signs. So we're going to divide negative 1 by negative 4. And then we're going to divide x by negative 4 and then 11 by negative 4. So this actually should become a positive. Okay, I'm going to make that a change there. This is going to be a positive 1/4 here. Is greater than x is greater than negative 11/4. Okay, so that's your final product there. The key concept is here is that you always have to isolate the absolute value portion before you do anything else. If you start to solve with a number being added or subtracted from that absolute value, everything is going to be wrong, right? So make sure you do that first. Finally, we're going to solve a word problem, and here it is. You're buying a new computer and you find 10 models in the store priced at all these prices that are listed here. Okay, 10 different models, 10 different prices. So what they want you to do is find the mean of the computer prices. You remember what that is. That's the average. Total all the prices and divide by the number of computers. And then you know that you're willing to pay the mean price with an absolute deviation of at most 100. Remember, absolute deviation is an absolute value that you're willing to go up or down. You're willing to change your price by that amount. So we're trying to see how many computers meet our conditions of $100 plus or minus the mean. So the first thing you have to do in step 1 is calculate the mean. We're going to add all the prices and divide by the number of computers. So the mean actually equals 664. I took the sum of all those computer prices and I divided by 10. Okay, you can easily do that. In step 2, however, we want to write and solve an absolute value inequality, and the deviation is 10. To do that, you have x, the amount you're willing to spend, minus the mean. So it's the variable minus the mean has to be less than or equal to the absolute deviation that you're willing to tolerate. So he's willing to put up with $100 plus or minus. So we're going to rewrite that because it's a less than. So we have negative 100 is less than or equal to x minus 664 is less than or equal to 100. When I add 664 to each side of this inequality, I get 564 is less than or equal to x is less than or equal to 764. In other words, I'm willing to spend $764 or $564 or anywhere in between that meets my criteria of leaving the mean by 100. In other words, my absolute deviation, the amount I'm willing to change from the mean, is just 100.